Good afternoon, students. If any batch 1 students logged into the classroom, you may leave. Actually, this is only for batch 2. So previously, I've shared a Google form for batch 2, but many of the batch 1 students have filled out that form. So that's the reason why batch 1 students also received the class credentials. Next time, I'll remove those mail IDs from that list. Actually, officially, I didn't receive all the registered students till now. I received only few students. I mean, before we are changed in the technical elective, that student list is fixed, but the remaining students list I've not received officially. But still, I've collected the mail IDs and then I'm sending the credentials. And regarding the Google Classroom invitation, all the students received. And few students who have changed their technical elective, they did not receive. If this is the case, you please mail to ITKM, including me and CC. They will add you. They'll send you the Google Classroom invitation. If it is in my hands, I would have already shared you that Google Classroom invitation, but that will be done by ITKM. Okay. Yeah. And even if batch 2 students, you receive batch 1 credentials on Monday, Tuesday, have you received? Did any of you received batch 1 credentials? I think
for day before yesterday and yesterday I didn't receive anything. This is from my section, typically G section. I'm pretty sure.
So your batch 2, you did not receive from batch 1 credentials, right?
No, ma'am.
Yeah, so the problem is with batch 1 only because they have entered the details in batch 2 Google form. So by mistake, all of them received the credentials of batch 2 also. Yeah. If batch 2 receives credentials of batch 1, that is on Monday, Tuesday, you no need to join. I don't consider the attendance also. You don't need to join. That's what I want to say. Okay. Okay, let me discuss the topic. In the previous class, we discussed what kind of data can be mined. So one is databases. Yeah, we have discussed about the databases. And next one is a data warehouse. We can mine the data warehouse. And next, third category. So that is today's topic, transactional data. So transaction means a unique identity with a list of items which creates a transaction. I mean, every transaction will be having two fields. One is unique identification and next one is list of items purchased in that transaction. This is the transactional data set. You can see here. Naveen, so you're saying cryptocurrency example?
Yes, ma'am.
Yeah, I don't have complete idea on cryptocurrency. Can we include it in transactional data set?
Yes, ma'am. We can.
For example, Naveen is having certain ID. So what could be the second column there?
Ma'am, first when we need to transact, we need a receiver ID. Then after we send transaction will be validated, ma'am.
Okay.
Validated in a block.
Yeah. Let me clear. So you're considering this transaction as banking transaction, similar to banking transaction, right?
Yes, ma'am.
Okay. So, but here transactional data refers to retail and e-commerce data. You can consider it as.
So ma'am, it is basically like a product having its unique transaction ID or unique product number, right?
Yeah. Every transaction will be having a transaction ID, which indicates the customer, identification of that purchase and list of items purchased by the customer during that transaction. For example, T100 For example, one customer entered the market, maybe in online also, online transaction also, and then purchased, selected some items or products, and these are the product IDs or item IDs, that is 1, 3, 8, 16. Instead of product names, I have included the product IDs here. So 1, 3, 8, 16. So as this customer purchased these 4 items, this will be one record in that transactional database. Okay, so this kind of data is called transactional data. Why we are specifically discussing about this transactional data is, this is main for association rule mining, which is one of the important pattern mining in data mining. Association rule mining is one of the data mining tasks or the functionality which needs the data of this form. Okay. So this is a fragment of the transactional database for All Electronics. So All Electronics is an electronic based company. So this I've considered as the fragment. It's a part of that database. Okay. It's not the complete database, it's a part of the database which indicates the transaction ID and some list of item IDs. So, and one more is, a transactional database can be stored in a flat file, in a text file. Even you can store this transaction information in a text file or in the form of a table. In either way, you can store the transactional data. It can be stored in a 2-column table, or you can store it in a text file also, flat file. And mining transactional data. Yes, we can mine this kind of transactional data. For example, which items sold well together? What is the frequency of multiple items? For example, item 1, item 2. How many times these 2 items were purchased together? How many times item 1, item 3 were purchased together? So finding out all these will result in the item sets which are purchased more frequently, which is called mining frequent item sets. That is, set of items which are frequently sold together. So this is the first step for association rule mining, finding out the frequent item sets. Only once you know the frequent item sets, then you can go on generating some rules called association rules, which describes the association between the multiple items present in that list of transactions. Okay. So this is one kind of data on which we can perform mining. And the different other kinds of data I've included here. We can have a time related or a sequence data, which includes the historical records, stock exchange data, time series data, biological sequence data, all the data which includes a time factor or an order between them. So these are time related or sequence data. And the data streams, a stream of data, continuous flow of data. For example, CC camera footage, it will be continuous, right? Sensor data, that is video surveillance and sensor data. These are data streams where the data will be continuously transmitted. Next, spatial data, which includes the map data, medical images, all these spatial data. And next, engineering design data. So designing of buildings, some system components, integrated circuits. Okay. Next, hypertext and multimedia data. So yeah, it includes textual data, images, video, audio, multiple media, not only the databases or the data warehouses or the data in a table formats. We can even mine the unstructured data. So this multimedia data indicates the unstructured data. Textual data is unstructured. Okay, web, if you consider the web data, yeah, I have included that web data. So it's most of the data will be unstructured. Databases can handle only structured data, but there are more unstructured data in real time. Okay. Yeah, graph and network data. Example, social networks and information networks. So web data, it's a huge widely distributed information repository, which is available over the internet. So all these are different types of data on which we can perform mining. Yeah, that is what kind of data can be mined. Next one is what kind of patterns can be mined. Means what kind of patterns can be generated by the data mining functionalities. Okay, so data mining functionalities, this specifies the kind of patterns to be discovered. And next, data mining functionalities can be either descriptive or predictive. You can classify any data mining functionality as descriptive, and the next category is predictive. So descriptive mining means it will characterize the properties of the data in a target data set. So given a query related to some part of the data set, we can characterize its properties. That is a descriptive mining. And predictive mining is, it is performing some induction on the current data in order to make the predictions. You are performing some predictions on the existing data. So I'm trying to find out the unknown data. That is prediction. Okay. And if you consider the data mining functionalities, we have a list of 6 functionalities here. Data characterization and discrimination. And second one, mining frequent patterns, associations and correlations. Third one is the classifications. Next, regression, clustering and outlier analysis. So all these are different data mining functionalities. So what do you mean by descriptive mining? It will describe the data. Means it will determine the existing similarities in the data and finds the existing patterns. Okay, so it will actually, this kind of descriptive mining tasks will answer the questions such as what happened. So we have a certain data, it will find out it will give the answers to questions such as what happened. Okay, so yeah, I'll give you some examples in the next coming slides. And coming to this data mining functionalities, clustering and association analysis can be categorized into descriptive mining tasks. Okay, so we'll see them. Predictive mining means, yeah, predicting the future results. So there will be some data variables which are unknown and which are known. So we'll use the present data to predict the unknown data values. So some forecasting techniques will be used. It will understand the future and answers the questions such as what could happen. What happened is descriptive mining. What could happen is predictive mining. For example, forecasting the customer behavior and purchasing patterns in order to identify the trends in sales activities. And also determining the probability of the customers making the future credit payments on time. So this is one more example. This classification and regression tasks, these both are predictive mining tasks. Okay. So if there is a target variable to predict the value, then that task will be predictive mining. There will be a target variable for which you need to predict its value. That kind of task is predictive mining task. The other is descriptive mining. So this is the first functionality, data characterization and discrimination. So data characterization is it summarizes the general characteristics of a target class of data. It will give a description about the existing features of the target class of data. For example, you want to know the customer's information who spend more than $5,000 a year per year at All Electronics. So the customers who spent more than $5,000 a year at All Electronics company. So what could be the result of this data characterization is based upon all the features of the customers. So it will do this mining task and then it comes out with, so you can see the second statement here. The users who are 40 to 50 years old and who are employed and who have excellent credit ratings, or the persons who spend this amount of money or more than this amount of money per year at all electronics company. So given this kind of query, this kind of result will be expected. Okay, so it's analyzing the features of customers based on its age and also whether their employment status and also their credit rating information. So this is, yeah, any doubt? Okay, fine. Next, data discrimination. So data discrimination means it's a comparison of two classes. It compares the features of target class against the features of one or more contrasting classes. Comparison of two or more classes of data. For example, so you are asked a question that is, compare the features of software products. So you are asked to compare the features of software products whose sales increased by 10% last year against those products whose sales decreased by at least 30% during the same time period. So this kind of query can be answered using data discrimination. Okay, so you are comparing the sales of the software products whose sales increased by 10% and whose sales decreased by 30% at the same time during the same time period. Okay, you are comparing. So this kind of task is data discrimination. So data characterization is describing the existing features of the data, whereas discrimination is comparing the features of two different classes. Okay. So how can you view the result of data characterization and discrimination? So you can present the result in pie charts, bar charts. You can use curves, multidimensional data cubes, multidimensional tables, crosstabs, rules. Even rules can be used, which are called characteristic rules or discrimination rules. So there are different ways of representing this kind of knowledge. And second one is mining frequent patterns. So you know what is the pattern? Pattern is the result of any data mining task. Okay. So the patterns that occur frequently, the pattern that occurs frequently in data is called a frequent pattern. So the frequent patterns can be frequent item sets, frequent subsequences, or frequent substructures. Three kinds of frequent patterns are identified here. Frequent item set refers to set of items which appear together often in a transactional data set. That is a frequent item set. For example, you consider the items milk and bread. So these are frequently brought together in grocery stores by many customers. So this could be a frequent item set, milk and bread. Similarly, if you consider a sequence of purchases, like a customer brought a laptop, and later in his next arrival, he purchased a digital camera and next a memory card. So this is a sequential pattern. If this kind of pattern exists frequently in the transactional database, then we call it as a frequent sequential pattern. A laptop tends to digital camera, which tends to memory card purchases. Okay, an order exists. Same customer repeatedly visiting the store for different items. Okay. So this kind of pattern is called frequent sequential pattern. And also we can perform this mining on different structures, different data like graphs and trees. We can perform on graphs and trees, which results in frequent substructures. Okay. So we can, community discovery is one of the best example for this frequent substructure mining. We know in case of Facebook, every data will be treated in the form of a graph. Not only Facebook, any social network will be represented in the form of a graph. So community discovery is one of the subcategory, which is a main problem there. So that problem can be solved by using this kind of frequent substructure mining. Okay. And association analysis, this one, finding out the frequent item sets or frequent sequences. So all these leads to association analysis of the items. Okay. So here you can see an association rule. Association analysis refers to generating the association rules. You can see here. Yeah. So this is the rule. I mean, this arrow mark consists of antecedent and consequent. Left hand side is antecedent and right hand side is consequent. So what is at the left hand side? X is a customer who buys computer and X is a customer who buys software. So this is a rule actually. So computer tends to software. So this is an association rule generated from frequent item sets. Frequent item sets. So here every association rule will be having two measures which gives the strength to the association rule. So they are support and confidence. Support and confidence are the two measures. Okay. So these are the two measures. So first I'll give you about this support. So here, what is the support? 1%. They are saying support is equal to 1%. How will you calculate this? How will you calculate this support and confidence from the given transaction data set? For example, you are having 100 transactions, means 100 customers have arrived at the store and 100 transactions have been done. So among them, if you consider the items computer software, so 50 customers, for example, 50 customers purchased computer as well as software. 50 customers purchased computer as well as software. Then the support will be number of transactions in which these two items appear, that is 50, divided by total number of transactions. So total number of transactions, how many? 100. So support will be calculated as 50 by 100. So in that way, we'll calculate the support. Here for this rule, they are saying 1%. Okay, 1%. That is 1 divided by 100 means out of 100 customers, only one customer purchased this computer and software. So 1% support means that 1% of all the total transaction customers, these two items, computer and software, are purchased together. That is the meaning of support. Okay, so if 50 customers purchased both computer and software in overall 100 transactions, then 50 by 100. That will be its support. And coming to confidence, so here confidence means, so in order to make you understand simpler manner, so you know, among 100 transactions, 50 transactions contains both computer as well as software. So yeah, 50 given how many transactions have computer, total number of transactions in which computer exists. For example, if 70 transactions have this computer, then its confidence will be 50 divided by 70. 50 divided by 70 will be the confidence. Okay. The number of transactions in which both the computer and software appear, given the number of transactions in which only, computer also exists. That is confidence. So a confidence or certainty of 50% here means that if a customer buys a computer, there is a 50% chance that he or she will buy software also. Actually, these two rules, these are the strength of a given association rules. Okay. So support will refer to how often the rule appears in the database being mined. How often the rule appears in the overall transactions. So number of transactions in which both items appear divided by total number of transactions. That is support. Whereas confidence means it refers to amount of times a given rule turns out to be true in practice. Means both computer and software were purchased, and in how many transactions computer exists actually. That is probability of A union B given probability of A. That is conditional probability. Confidence is calculated using conditional probability. Okay, probability of A union B. A means the left hand side of the rule. B is the item which is present in the right hand side of the rule. A union B divided by probability of A. That is computer. Probability of computer software divided by probability of computer. So that is confidence. Okay. Any doubt regarding this support and confidence, students? I'll give you a quiz now. So you'll be getting bits in this topic. So you better clarify now if you have any doubt. So in overall transactions, how many times these both items occur? That will give you the support. In the transactions in which computer is purchased, how many times software also is purchased? That is confidence. Is it clear, students? So the support and confidence are the two measures which give strength to this association rule. Okay. So what do you mean by support equal to 1% here? Out of 100 transactions, these two were purchased only one time. Okay. Yeah, Akhil asked a question. Ma'am, can confidence used for software also, like computer and software? Use software. Yeah, the left hand side and right hand side, these need not be a single items. They can be even item sets also. It can be item sets. Software gives rise to computer. That rule is also possible. We can have any rule. Computer tends to software or software tends to computer, but all it depends based upon the support and confidence. So to which rule the support and confidence are high? Okay, the rules which are having highest confidence will be strong association rule. If these two measures are high, then we call them as strong association rule. Okay. Any is it clear, Akhil?
Yes, ma'am, it is clear.
Yeah. So first, for generating this kind of association rule, the first step is we need to find the frequent item sets. Only once you find out the frequent item sets, then only we can generate this kind of rules. So there are many algorithms for generating these association rules. We can't do it manually, right? Is it possible to calculate manually among some lakhs of transactions? No, it's not possible. We have algorithms. Okay, we'll discuss those algorithms in our second unit, association rule mining. Okay, once the frequent item sets are known, then we can easily find out the association rules. So what will be the frequent item set? The item set which appears frequently. Who will decide that frequency? When running the algorithm, we can set the threshold. We can set the threshold. For example, out of 100 transactions, if the item set appears more than 80 times, then only we say it as frequent item set. We have set that threshold as 80%. Or if you set to 50%, then different frequent item sets will be generated. If you set the threshold as 60%, different frequent item sets will be generated. So that depends upon the threshold setting. Okay. This we measure this frequency. Okay, measuring the frequency is simple. In 100 transactions, finding out the frequency of each, finding out the frequency of computer, finding out the frequency of software, finding out the frequency of both the computer and software together. That's easy. Finding out the frequency is easy. And once you set the threshold, the item sets whose frequency is above the threshold will be frequent. Okay. Yeah. Yeah. You should have the clear difference between support and confidence. That's it. And next, association rules which contain a single predicate. Single predicate means here BICE. BICE is a predicate here. So it's called as single dimensional association rule. Okay. Yeah. If you, in case of single dimensional association rule, you can even drop that predicate. See here, computer implies software. The first one is treated as support. The second one is treated as confidence. Okay. So this is a single dimensional association rule as we have only one predicate. And yeah, let me discuss the multi-dimensional association rule. Means we have more than one predicate. Means we are describing the rule. We are generating the rule using, in this example, we are using age, income, and we are finally generating the rule for the laptop. See here, the age of the customer X is between 20 to 29 and income of the customer is between 40,000 to 49,000. Then the customer X buys laptop with a support of 2% and confidence 60%. So what is the meaning of this association rule? So 2% of the customers who belongs to this age group 20 to 29 and whose income is between 40 to 49K, okay, have purchased the laptop. At All Electronics company. So this is the meaning of this support of this rule. Similarly, there is a 60% of the customers who are under this age category and under this income category purchased laptop. Among all the customers who are in this age group and in this income group. We are not comparing with all the customers, only with the customer group whose age is 20 to 29 and income is 40 to 49. That is confidence. Okay, 60% probability that a customer in this age and income group will purchase a laptop. Yeah. So if an association rule has more than one attribute involved here, that is a predicate. We said this is predicate, right? So if more than one attribute is involved here, then we refer as multi-dimensional association rule. Okay. Finding out the single dimensional association rule is simple compared to multi-dimensional association rule. Next, classification. Yeah, so already I have given you some introduction to classification. So let's discuss some more examples here. So classification is, it is a data mining technique. Okay, so mainly it has two steps. One is it builds a model. It builds a model by training the data. We already have the data with certain classifications. This record belongs to this class. This record belongs to this class. So we have already class labels and the data, which is called the training data. We use this to build a model. That is the first step. And second step is this model will predict the label of the data whose label is not known. Means a record whose class label is not known will be given its class label. So this classification technique is a prediction technique which predicts the target variable whose class is not known. Okay. So for example, classifying a large set of items in the store based on 3 kinds of responses to the sales campaign. Good response, mild response, no response. So here, in order to create a model for this, we should already have some items information in the store, and each item must belong to either of these 3 categories. The item can be either good response, mild response, or no response for that item. So if some item arrives and if you want to classify this as whether it is good response, mild response, or no response, then this model helps you to classify that new item, whether it will be in good response or mild response or no response. You are finding out the target class label in case of classification. So you are building the model and then you are predicting the label of an unknown variable. That is classification. Yeah, so how to present this classification knowledge? One is you can use classification rules such as you can see here. So this is not an association rule, don't get confused. This is the classification rule. So here we are saying that if customer age is youth and income is high, then he belongs to class A. Class A. If customer age is youth and if his income is low, then the customer belongs to class B. And if customer age is middle aged, then we classify as C. If customer age is senior, then also we classify as C. Okay, so these kind of rules. So this is the model actually. From the given data, we have generated a model which is represented in this form of classification rules. Now, if a new customer record arrives, so based on the customer age and income, we should predict the class label of that customer Y, a new customer. Okay. Now, similarly, decision tree. We can use the decision tree model. It looks in this way. It contains nodes and edges between the nodes. So node represents the feature. Each node represents the feature, and every edge will be having a value of that node. For example, age. If age is youth, if age is middle-aged or senior, if age is youth, then we are going for the next feature, that is income. If income is low, then the class is B. If income is high, age is youth and income is high, then we are categorizing to class A. If age is middle-aged or senior, then we are categorizing the record as class B. So this is the decision tree model. This is one more way, and also we can use neural networks. This neural networks, it will be having so input as well as output, and multiple layers of nodes will be there. Input layer will be set of features which leads to the class label, and finally the last layer will be output class labels. Okay, and in between we'll be having multiple layers, one or more layers will be there. So neural network is also one of the model to present the derived model. So about this classification we'll discuss in our third unit. In third unit we'll discuss classification and regression. 1 second, students. Next, regression. So regression is, yeah, it is also a prediction technique. It predicts the missing or unavailable numerical data. Yeah, I'll conduct the quiz, just 5 minutes. After 5 minutes, I'll conduct the quiz. Okay. Yes. Slides are there. So till outlier analysis, I'll complete and then I'll conduct the quiz. Okay. Yeah. So after quiz, will you leave the class? Is this the reason for asking for quiz?
No, 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 ma'am.
Yeah. Okay.
Hmm.
So I do know because listening 90 minutes in continuous manner is difficult. So we need a break.
Yeah, ma'am. What if I just go to washroom and you take the quiz? So
Okay. No
Ma'am,
problem.
it's like you can have a quiz and then have a break of 5 minutes or something, and then we can continue.
Actually, I've included some questions on this next topics on outliers. That's fine.
Okay,
You
ma'am.
can take 5 minutes break, no problem. I'll start at 2:05. Yeah, I'll start at 2:05. Instead of 2:50, I'll be continuing up to 2:55. Is it okay? Yeah, you can have 5 minutes break. Okay, students, let me start. So regression is used to predict the missing or unavailable numerical data rather than the discrete class labels. So here we are going to predict the numerical values. So it's a statistical methodology which is used to predict the numerical values. For example, you want to predict the amount of revenue generated by each item in the upcoming sale. You're going to predict the amount of revenue generated by each item during the next sale for a company based on the previous sales data. So you're having the previous sales data. Based on the previous sales data, you're going to predict the revenue generated during the next sale. So you're predicting the amount. Okay. So that is a regression. If you predict the discrete class label, then that is classification. If you predict the numerical value, then it will be a regression technique. Yeah, cluster analysis. So you can't find the data always with class labels. So what to do in that case? In that case, you need to do grouping of the data based on their similarity. So this technique is clustering. So if class labeled data do not appear in the beginning, then we'll create the class labels based on the features of the data. We'll group the data based on its existing features. Finally, after generating the groups, for example, if you have generated some 5 groups after performing this clustering technique, now we'll label each group. Okay, so that is clustering. So objects or the data points within the cluster will be having high similarity compared to objects present in other clusters. Other clusters means interclusters. Same cluster means intra-cluster. So intra-cluster similarity will be high, inter-cluster similarity will be less. Okay, so this is clustering. So all the data can't be labeled at the first time. So in that case, how can you perform this? How can you perform this segmentation kind of thing? So we can do with the help of clustering. Clustering can be used to group the data based on the existing features. Okay, and then later, if you want, you can label them. You can see a 2D plot of customer data here. So this is the data with features called locations. Based on the locations of the customer, we have drawn these data points. So it shows the 3 data clusters which are surrounded here. So these are the data clusters which are near locations. Near locations are grouped under one cluster. And what are all the points which are very far away from these or treated as the outliers? They are called the outlier data. Means they do not belong to any group. If they do not belong to any group, then that is an outlier. Okay. Examples of classification. So yeah, let's see a few examples of classification and clustering. The first one, yeah, we have consider the hospital management system. We have an emergency room or the ICU. Okay, so we have 17 variables which characterizes the patient, blood pressure, age, like that. So for a newly admitted patient, you need to decide whether this patient has to be admitted into the ICU or not. So ICU is costly, right? So due to the high cost ICU, so those patients who may survive more than a month will be given higher priority. Okay, so here the actual problem is we have to predict the high risk patients. We have to find the high risk patients and you have to discriminate them from low risk patients. So what are the classification here? High risk patients and low risk patients. So this is one example. And coming to credit card application, so a credit card company receives some thousands of applications for new cards, and the application may be having the information such as the annual salary, debit information, age, all these. So here the problem is we have to categorize the applications into good credit or bad credit. In order to issue the credit card, we have to categorize the applications into either good or bad credit. Okay. And email spam, finding out the spam mails. Here the goal is, the problem is predicting whether an email is spam and should be delivered to the junk folder. So this is also an example of classification. And coming to clustering, yeah, customer segmentation. You're performing the grouping of customers here. So you're grouping the customers such that each customer segment will consist of customers with similar market characteristics, similar pricing, loyalty, spending behavior, that is the purchase behavior. So based on all these characteristics, you are finding out the customer segments. Okay. Yeah, number of items purchased in the sale, average transaction value, total number of transactions. So if the customer segmentation is done, then it could help the market analysts or decision makers to design some strategies for targeted customers, to design some discounts or any strategies for improving their sales based on the group of customers. And next, document clustering. So here this aims to group the related documents. So the document relevance is based on the contents present in the document, whether it is related to politics, entertainment, sports, culture, art, and so on. So this is one of the application of clustering, document clustering. So only if you have the related documents under one group, then only if a query related to a particular document is given, so all the documents will be retrieved, right? So related documents, if they are located at the same place, then they can be retrieved and then they can be efficiently given as the result of the query. So grouping of the documents. Yeah, and one more data mining functionality is outlier analysis. So this outlier is, it's a data point or an observation which appears inconsistent compared to the remaining data. It will be inconsistent with the remaining set of the data. It will not follow the behavior of the data. For example, if you see some set of exam scores or something like this, 25, 29, 3, 32, 85, 33, 27, 23, all these are different scores. So among these scores, if you consider 385, they are very far from the remaining data, isn't it? 3 and 85 are very far from the normal data, 25, 29, 32, 33, 27, 28. All these are at, or they're similar, but coming to the 3 and 85, they are the points which are very far away from the remaining data. So these are called outliers, which remain inconsistent with the other data. So for example, in case of applications such as fraud detection, it's helpful to find out the rare events. Rare events will be more interesting than the regular ones. So outliers will not be appearing frequently, right? They are treated as rare events. Okay. And this analysis of outlier data is said to be outlier analysis or anomaly mining. It's also called as anomaly mining. For example, a banking customer actually deposits not more than $1,000 per month. Okay, he will not deposit not more than $1,000 a month in and at a local ATM, and suddenly if he deposits two cash deposits of $5,000 each in the span of 2 weeks. Okay, so this will be treated as a global anomaly. For example, a customer will not actually, he will not withdraw more than 10,000, for example. If all of a sudden, if 50,000 or more than that is withdrawn, then that will be treated as an outlier, an anomaly. Something fraud is being happened like that. Okay. Maybe your ATM card, you have lost the ATM card, or some other maybe using your ATM card, because your regular transaction is not that much amount. Suddenly, if this large amount happens, then it will be treated as the anomaly or outlier. And also discovering the fraudulent usage of credit cards by detecting purchase. Yeah, whatever I have said. Detecting purchase of unusually large amounts for a given account number compared to regular charges incurred by the same amount. If regularly you are using the credit cards and the amount is not exceeded by more than 10,000, all of a sudden, if 1 lakh is done, maybe that is treated as an outlier. Okay, so yeah, this is about outlier. Okay, and then so we have completed two concepts. One is what kind of data can be mined and what kind of patterns can be generated. And next one is stages of the data mining process. Okay, let me conduct the quiz and then we'll continue with this topic. The time is 2:20, so by 2:25 I'll end it. Last 1 minute.
Ma'am, opening the form takes 1 minute, ma'am. Ma'am, how can you just give that less time, ma'am?
No.
Thinking also takes time, ma'am. Clicking also takes time, ma'am. Everything takes time,
5
ma'am.
minutes is more than enough for 5 bits. Unless you do on your own, 5 minutes is enough.
Ma'am, doing on own only takes time, no, ma'am?
No. I mean, these bits are based on today's class itself. You can quickly recollect and then you can say answer.
Ma'am, just doing, ma'am, more 1-2 minutes, ma'am.
Yeah, quick. Yeah, time up. Okay, let me release the scores. You can check your scores. Let me discuss the answers. Yes. So clustering is a predictive mining task. No. It's a descriptive mining task. The answer is false. Identify the outliers from the given height measurement in feet. Yeah, obviously 1.2 is an outlier in this data. The data is 5.2 feet, 5.3, 5.4, 5.1, 1.2. So answer is 1.2. Yeah. So what is the confidence of the association rule? A implies B. If item A and item B are purchased only by one customer among many customer transactions. So how will you calculate the confidence? Number of transactions in which item A and item B are purchased. We are saying that only one. Okay. Item A and item B are purchased only by one customer among many customer transactions. So 1 divided by number of transactions in which item A exists. As I have mentioned, only one. So it will be 1 by 1, which will be 100. What's that? Durga.
Ma'am, we don't know the denominator now.
1 second. Durga, it's okay, Durga. You can attempt the next quiz. Don't worry. Yeah, actually, so some little confusion in this question. So, yeah, actually, I want to say that only one transaction contains these items, and in these items will not appear in any other transactions. That should be included actually. So, if that is the case, then it will be 100%, right? 1 divided by 1. If item A also exists in only one transaction, yeah, I think most of you have written can't say. Okay. As there is a problem in the question. First time when I prepared, I thought item A appeared once, item B appeared once. So item A and B appeared together means 1 divided by item A also appeared only once, 1 by 100. But the meaning of the statement is different. It shows that item A and item B are purchased only by one customer among many customer transactions. Yeah, so definitely you can write can't say also. So it's okay. I'll change it. And this one, in the above question, what is the support of the rule? We can't say because we don't know the total number of transactions. We don't know the total number of transactions. Only if total number of transactions is known, we can calculate the support. We can't say. Which technique predicts the value of the target variable? I think this question also many of you missed it. The answer is both. Both the techniques are used to predict the value of the target variable. Classification also predicts the target variable value. It can be a label. It can be either a discrete label, that is classification. If it is a numerical value, then it is prediction. Any question? Somebody is asking.
Ma'am, in classification, the only like class label is predicted, right? The value is not predicted,
Target
right?
variable. That is
I mean,
value means do you refer only?
I thought it was numeric.
No, how can you thought? No. That's why I've mentioned predicts the value. It's not, I have not mentioned whether it is numerical or discrete value. Okay, so the answer is both the above. Fine. Any other questions, students? Can we continue with the next topic? Okay. So stages of the data mining process. So we call this as knowledge discovery from data process, KDD process. So we have two steps here, two stages, not steps, two stages. One is first stage, which is called a data preparation or data pre-processing stage, where we use some techniques for pre-processing the data before the actual processing. We are preparing the data for mining. That is the first stage. You are preparing the data for mining. So in the second stage, actual mining will be done, and then the generated patterns will be evaluated and knowledge is represented. So these are the three steps involved in second stage. I'll show this. Yeah, you can see here. Databases, flat files. Collect the data and it represents a data warehouse repository. So before loading the data in the data warehouse, we'll perform data cleaning and integration. Data cleaning means we are removing the inconsistencies, and we are removing the noisy data and handling the missing values. All these come under data cleaning. And then we'll integrate the data from multiple sources. Data warehouse will be created. Okay, next is data selection and data transformation. So data may be having many features, out of which many are not useful for mining. So we have to select few attributes which are relevant for mining. That is selection process. And next, transformation means you're converting the data into a simple form or a form which is suitable for mining. You're transforming the data into some other form which is suitable for mining. We'll discuss all these in the later slides. And so this is the first stage actually. After that, the second stage consists of actual data mining, where the intelligent algorithms and methods are applied here to find out the patterns. So these patterns will be evaluated, means all the patterns generated may not be interesting. So we can evaluate the patterns and find out which are really interesting, and then represent the knowledge. Presenting the knowledge. So this is the final output. And the user may interact with any of these steps. So this person, so she's the user, represented as the user here with some tools. So can interact with any of these previous steps in this entire process. And this knowledge discovery is an iterative process. So once the knowledge is derived, so based, if you want to refine this, we can include some new data and then repeat the process. So we call this KDD as an iterative process. So we have exactly two stages in this knowledge discovery from data process. Data mining, some people, some authors, they say that both data mining and knowledge discovery from data as same. But many of them argue that data mining is not same as a KDD. Data mining is a single step in KDD process. So data mining is different from data mining process. So that process we call here as knowledge discovery from data, KDD. So in this KDD process, data mining is a single step. Okay, yeah. Before mining, we have some pre-processing. After getting the results, also we have some post-processing work. So data mining is actually a step in this knowledge discovery from data process. And next, yeah, as we discussed in the first stage, we have cleaning. So real world data will be having an incomplete data, noisy and inconsistent data. So data cleaning will handle all these three issues by filling the missing values, removing the noises, that is identifying the outlier data. Outlier data, sometimes it is treated as the noisy data, and we need to correct the inconsistencies in the data. If data do not appear to be similar at all the places, then we call it as inconsistent. So this kind of inconsistencies have to be handled before mining. So this is data cleaning. So we have many techniques for handling all these issues. These will be discussed in your second unit. First part of your second unit deals with the data pre-processing. There we'll learn what are all the techniques for data cleaning. Okay, so this is just an introduction to that data pre-processing. Okay. Yeah, I have given an example for missing data. See, so yeah, so it is possible that people with low incomes and very high incomes, they will not be entering, or they will not be interested to answer that question. So they will not be revealing the income. So this will affect the credit risk assessment. And similarly, in case of patient hospital data management, the patient registry may be missing some laboratory values of a particular batch, means lab samples may be missing, or they may be processed improperly. That is one example. And if you consider the house price estimation data set, the housing model will use some information such as number of rooms, land size. So these are used to predict the home price. If actually, if for a 2-bedroom house, there won't be value for the size of a 3rd bedroom, right? So if such kind of entries exist, then that field will be empty. So designing the efficient entry form is also required. The entry forms must be designed in such a way that missing data should be very less. Okay. Noisy data. So yes, noise is a random error in a measured variable. For example, you may get faults in sensor devices, or data transmission problems and data entry problems. So all these will be handled by data cleaning. The impure data will be pure. That is the symbol of this. This I have collected from your textbook. Yeah. So coming to data integration, this is the next step, merging the data from multiple data stores. So here also we have to face some data integration issues. One is entity identification problem. If you're collecting the data from multiple data sources and merging it in a single place, then how can you match up the real world entities? Example, one database may be using customer-ID in the database, and some other database may be using cust_number. We have to identify two real world entities when you merge. Okay. And also a discount. There is an attribute called discount in two databases. So they have simply used the name discount. So one database may be applying the discount to the total order, whereas one database system may be applying the discount to specific item within that order. So this also differs, right? When you are merging the data, when you are grouping the data at a single place, then you need to handle all these issues. That is data integration. This is also one of the pre-processing. Yeah. One more problem with data integration is it leads to redundancy, redundant data. If you are merging multiple data stores, there is a chance that attributes will be redundant. So for example, we can say an attribute as redundant if it can be derived from one or more other attributes. If you can derive it from one or more other attributes, then we can say that attribute as redundant attribute. For example, age. If you know the date of birth, we can derive the age. So what's the use of maintaining these two attributes in our database? No use. So yeah, so this is one example for redundant attribute. Age can be derived from date of birth, so no need to maintain this. This will be treated as the redundant attribute. Or combining the data from multiple stores, forming a single data warehouse. Yeah, data transformation, converting the data from one form to another, so that it will be efficient for mining. That's the only reason. For example, if you consider an attribute called age, so age will be having how many values? Many values from 1 to 100 or 150, like that. Age of a person. Maximum 100, minimum 1, like that. So if many values exist, then we can handle them by transforming them to next level concepts, higher level concepts, such as so youth, adult, senior. So based on the age value, I am categorizing any age value to either youth, adult, or senior. For example, 1 to 25 youth, 25 to 50 adult, greater or equal to 50 senior, like that. Okay. And similarly, annual income. So annual income will be having large value. So you can transform it or normalize it into a smaller range. You can normalize it to a smaller range between 0.0 to 1.0. This kind of transformation is also possible. We use some normalization techniques such as min-max normalization, z-score normalization, decimal scaling. These normalization techniques, yeah, we'll discuss in our second unit. Okay. So here I have mentioned you a simple example, which is the decimal scaling example. You can see here -2, 32, 100, 59, 48. All these will be, transformed to lower scale by dividing it with 100. That is divide by 10 square, 10 powers. To divide the numbers by 10 powers, that is the decimal scaling. So it will be converted to 0.0 to 0.32 on up to 0.48. So attributes on different scale will be leading to poor data models. So in order to perform data mining operations, we can bring all the attributes on the same scale. This can be done by applying the data transformation. Yeah, it's a normalization technique. So whatever the example I have given here, this is a decimal scaling normalization. Okay. Don't think about the normalization in your databases. That's different. That is not first normal form, second normal form. That is different. That is handling the redundant data, redundant records. That normalization is different. This normalization is different. Okay. Yeah. And data selection. So retrieving the data which is relevant to the analysis task. For example, you might have the data with 100 columns. We have to identify the minimum number of columns which are significant, which are useful. For example, you want to predict the likelihood of illness. It's patient's information. So patient information will be having many attributes. Maybe it is having the patient address, number of cards, so many. So they will not affect the prediction, right? So those attributes can be removed. Only the attributes which are required to predict the likelihood of illness will be selected. And similarly, in order to predict the student's grade point average, student ID, student age, his address, it's not relevant. All these attributes can be removed. Only the attributes which are required can be selected. Okay. Yeah. All this cleaning, integration, transformation, selection come under data pre-processing. So I've summarized all these steps here. So data cleaning, which removes the noise and inconsistent data, data integration, which combines multiple data sources, data selection, which retrieves the relevant data required for analysis, transformation, which transforms the data into appropriate form for mining. Next step, data mining, applying intelligent methods or algorithms to extract the patterns. Pattern evaluation means identifying the interesting patterns which represent the knowledge. Finally, knowledge presentation. Here we use some knowledge representation techniques in order to present the mined knowledge to the users. The mined knowledge can be presented to the end users. That is knowledge presentation. Okay. Finally, I want to conclude with goals of data mining. Yeah, here I have listed few goals. Actually, this topic is not present in any of your textbook actually. There is no concept like goals of data mining. But I've referred from Google. Yeah, someone asked a question. So is this introduction topics or learning depth like data cleaning? Yes, as I said, these were introduction topics. Later we'll learn in your second unit. In second unit, you have all these data pre-processing steps. So there we'll learn about how data cleaning can be performed, data cleaning techniques, and how what are the issues to be handled in integration, and what are the data transformation techniques. So all these. You don't have lab. You don't have lab. This is a technical elective. You have only theory, right? Yeah. If you want to do the lab session, then on your interest, you can use either C++ or Java, and you can consider any functionality, and then you can implement on your own. That is one thing. If you want to perform any of these, implementation, no, we don't have any lab session. Implementation will not be done.
Is this only theory based course?
Theory based only. I'll be teaching you all the algorithms required for performing mining. What are all the association rule mining algorithms? How they work? Okay, and what are the classification algorithms and how they work? Clustering actually it's not included, but if time permits, I'll discuss the clustering algorithms also, and how to perform the prediction algorithms. Okay, like that. Mainly your syllabus deals with association rule mining and classification algorithms. Okay. Yeah. Because implementation is simple, means we have many packages in your R language as well as Python. We have packages for doing this association mining. We have packages, frequent association rules can be generated, classification can be done, prediction can be done, clustering can be done, everything can be done in your using Python. But not that. Using a single function, you have to know the functionality. I mean, what could be the statements in that function which do this actual task? Okay, how the clustering algorithm is designed, working of the algorithm is required, not the name of the algorithm. So how the algorithm works, how can it be modified so that our algorithm works better than the existing algorithm? Okay, so in that way, I'll teach you this algorithms concept, I mean data mining algorithms. Okay, understood? Yeah. So I've collected these goals from searching in the internet. So actually nowhere these goals of data mining are present. Yeah, one is prediction. Prediction is one of the goals. So here we are determining how certain attributes will behave in the future. Okay, how much sales volume a store will generate given a time period. And identifying the patterns in the data. For example, newlywed couples, they tend to spend more money buying the furniture. Okay, so this is one kind of pattern. Next, classification, how to partition the data into multiple classes. So you can classify the customers into different categories based on their shopping behavior. Optimization, optimizing the use of limited resources such as time, space, money, materials, like this. Optimization is also one of the goal of the data mining. Okay, you can design the data mining algorithms such that efficiency and space, complexity, so all these will be the major issues. That is in case of algorithm design part. And generally, optimization can also be treated as optimized use of resources. For example, how to best use the advertising to maximize the profits. How can you maximize the profits? By using the advertising information. Like that. So these are the different goals. Yeah. Okay, students, I want to take the feedback from you because most of the first unit we have covered. Just want to know the feedback. I'll be sharing you a Google form. Just wait for a minute. Yeah, fill this form and then you can leave. So this form will not be receiving any of your mail ID, any of your identity will not be received. So you can enter your feedback. Yeah, for Google Classroom, you mail to ITKM. ITKM and CC to me.